All right. Hi, my name is Daniel, and I'll be helping you out today. So let's look at the question. We got 24.1 grams of SO2, sulfur dioxide, and 6.0 grams of oxygen. Now, oxygen exists in nature as a gas, so that's going to be O2, so 6.0 grams of O2. Combined to form sulfur trioxide, that's going to be SO3. How many grams of sulfur trioxide must form? So this type of question is called stoichiometry, and the first step you want to do before anything else for these type of question is to find the chemical equation. I'm going to share my screen, and I'll show you what I got. All right. So using this handy trick I use for balancing chemical equations, I get 2s2 plus O2, 2SO2 plus O2 equals 2SO3. And that's going to be your chemical equation for this problem. So the second step would be to find the limiting reagent. I assume you know what the concept of limiting reagent is. Basically, if you have a sandwich, a lot of bread, a lot of ham, a lot of cheese, you have a sandwich with a lot of bread, you have a lot of, I don't know, hamburger, ham and cheese. You only have a limited amount of bread you can make sandwiches with, even though you have unlimited amounts of ham and cheese. So bread's going to be your limiting reagent. Same thing here, but you want to use moles because moles are the standard unit you want to use to compare. So 24.1 grams of SO2, you want to multiply that with the molar mass of SO2. That's going to be 64.06 grams per mole. Make sure to cancel out the grams, and you get 0.376 moles of SO2. Same for O2, and you'll have 0.19 moles of O2. And now the question is, how do we find out which reagent or reactant, SO2 or O2, is limiting here? Which one's the bread, so to say? So we can look back at the chemical equation, and we can see that for every O2 that reacts with SO2, SO2 needs 2 moles. So basically, SO2 needs 2 times as many moles of O2 to react and form the SO3. So if we look at let's look at SO2. Let's consider that as limiting reagent. Let's see. We'll test it out. 0.376 moles of SO2. If we were to divide that, 0.376 moles of SO2 divided by 2 would be around 0.188. So it's going to react with 0.188 moles of O2. And now that's going to be but there's 0.19 moles of O2 in the starting reactant, which means that there's going to be some O2 left over. There's going to be some ham left over. Even though you had so much ham, you've only got a limited amount of bread, only got a limited amount of SO2 to make that SO3, and you can't use the remaining O2. Now, so SO2 would be the limiting reagent here. Now, if we look at O2, 0.19 moles of O2, you would require 2 times as much of that, 2 times as much of that moles of O2 to get SO3. So 0.19 times 2 would be around, let me do the math, 0.38, if I'm not, yeah, 0.38. And that's going to be more than 0.376, and we don't have 0.38 moles of SO2. So 0.376 moles of SO2 is clearly your limiting reagent here. All right, so now we identified a limiting reagent. So that's going to be SO2. You take those moles of SO2 and you do a molar ratio, multiply by the molar mass of SO3, and you'll find that we have 30.1 grams of SO3. All right, that helps.